So this is where we kick our programming skills up another notch. So we kicked them up quite a bit when we looked at if-else statements. So with if-else statements, we execute code based on a condition. If the condition is true, we execute the code. With loops, though, we actually repeat code based on a condition. We repeat code a certain number of times. With loops, anything that you might want to repeat again and again, that's what we put inside of our loop. Computers are very good at repeating things. In C#, we've got 4 different types of loops available. We've got while loops, we got for loops, we got do while, and we also have for each, which we'll look at when we take a look at arrays. Which type of loop you use is partly just your preference, and then it's also partly based on which one looks better in a given situation. The first 3 loops that I mentioned, you can convert one of those into the other, actually. Any loop you create, you can convert into the other. But again, sometimes some things look better in one loop than they do in the other. We'll see some examples of that. So the first loop is the while loop, and this is an example, a very simple example. It doesn't do anything practical, all it does is count. So here's main, and I declare a variable here called count that I initialize to 0. It's very important that I do something like that. The actual loop itself, though, is highlighted in yellow. So we begin with the keyword while, and then following is a set of parentheses that contain a condition. And then the body of the loop is what's inside these curly braces. So while this condition is true, we're going to do what's in the body. So if we take away while here and instead put if, now let's do that. Does that look valid? Does that look like a valid if statement? Yeah, sure it does. Only difference is if the condition is true, we're going to do this and then quit. But when we turn it into while, you're saying, as long as this condition is true, keep doing this. That's the difference. So if and while are very similar. Actually, all the loops are very similar to if statements. Just notice it's primarily that keyword difference. The condition is going to be just like we did with if statements. We create them just like we did there. We can use all the relational operators like less than, greater than, equal, all that to form conditions. We can also use logical operators like and, or. Okay, so we've seen those, and we can use those in those conditions. So whatever it is you want to create as a condition for your loop to run. So this is going to be the general form, the general format. So we're going to begin with an initialization statement somewhere before the loop. So it's going to be somewhere before it. So in this example up here, the initialization statement is actually this right here, where I declare what I call a loop control variable. Count is a variable that controls my loop. That's why we call it a loop control variable. But I'm initializing it right here, which is very important, before I go into the condition. And notice that count appears not only there, but it appears right here and also right here. Talk about that in just a second. So it's involved in telling my loop when to quit. So that's why it's called a loop control variable. Go back down and look at this again. So while, and then a condition. And then we're going to have code to execute if the condition is true, just like with an if statement. Except there's one critical thing here we've got to have. You got to remember to have an update statement. The update statement, what that does is changes the control variable. So for instance, up here on this one, that's my update statement right there. Plus count. What am I doing there? Adding 1 to it each time through the loop. So count is just incrementing each time through the loop. Hence, I called it count. I could have called it anything. It doesn't matter what you call it as long as it's a valid variable name. Now, so let's go through this loop and see what's happening. So I initialize this to 0. I go in first time. So the first time count is 0. 0 less than 4 is what? Is that true or false? It is true. So we execute the body, which means we come in here and we print out count, which is currently 0. By the way, that console write line, I just put that in there as an example. We could put anything we want in there as long as it's a valid statement, okay? So it's going to print out 0. Then this is going to increment to 1. Now, here's the trick. We go back up and check the condition again. 1 less than 4 is still true, so we execute again, print out 1, increment to 2, go back up, 2 less than 4 is still true, so we print out 2, go to 3, right? All right, 3 less than 4 is still true, print out 3, this time count becomes 4, 4 less than 4 is false, so we immediately pop out of the loop. We do not execute the body again. As soon as the condition is false, we pop out and execute whatever happens to appear after the loop. What if we did this? What if I did, so those are supposed to be comments. If I comment out, what do you think happens? So plus plus count is no longer there. It's commented out. It is, yeah. What number is it going to print over and over? 0. Exactly, because count never changes. That's a big problem. So we just created an infinite loop. There's no way for the loop control variable to update, so it's always going to go back and say 0 less than 4, true, 0 less than 4, and keep going and going and going, infinitely. All right? So now if you do create an infinite loop and you happen to run your program when it's doing that, all you do is press Control-C, or you could also up here when you run a program, there's gonna be a stop button up there. Let's see if I can do it. There it is. So you can press that stop button, or like I say, hold down Control and then press C, and it'll kill your program. Okay. Otherwise, it's going to keep running forever. So that update statement is very important, and it's usually going to appear at the end of your loop, somewhere at the end. I mean, it doesn't necessarily have to. Okay. These are just typical. One other thing too. What if I did say this? Correct. Yep, it would never start. Okay. So just like with an if statement, there's nothing that says that it's going to go inside and do something in it. So, so a while loop doesn't have to execute even once. Okay. It could execute 0 or more times based on how you have things set up.
Is there something like the else statement to go with this, or
no?
Is this just a
No, because you're not really making. I mean, you're not making. Well, you're making a decision about whether or not to keep executing, but other than that, you don't have any other decision to make. Now, you can put if-else's inside of a loop. You can nest if-else's inside of a loop, ifs inside of a loop. You can nest loops inside of loops, inside of loops, inside of loops. Keep going. Don't go too far because it starts getting messy. So you can nest all kinds of stuff inside, just like we looked at with if-else's. We looked at a bunch of nesting there. Let's see, the other thing too, just like with if statements, the curly braces are optional if you only have a single statement. So if I only had like a single statement, like, just one of those, I could leave off the curly braces. Any questions? Yes?
Why would the plus plus count go with the bottom? Is it just the easiest way to make it look neat, or?
Well, it's just typical. Well, let's say I did this. What would happen if I did that? How would that change it? It'll add it before it prints it. So like the first time through, 0 becomes 1, so we start with 1 instead.
Oh, it throws off.
It throws it out. I mean, it still works, but it's going to change the output. Okay? Because before it only printed out 0 to 3. Now it prints out 1 to 4. Because let's see, if count is 3, 3 less than 4 is true, so we come in, increment count to 4, so the last value printed is 4. We come back up, 4 less than 4 fails. Everybody see that? So by doing this, it changes the printout just slightly. Any other questions? Now this is very simple, and it really is this simple, but you can get a lot more complex code inside the loop, and there's all kind of possibilities. We'll see some examples later. The next kind of loop to look at is the for loop. By the way, a lot of languages have while loops, for loops, and do while loops. It's not just C#. All the C family languages like C, C++, Java, C#, they all have these same loops. But the for loop, because it's so common to have while loops that have an initialization and then an update, somewhere along the line programmers got together and decided we're going to create for loops that package this stuff into one nice neat little area. So this actually does exactly the same thing as the previous example. It has the same output, except this time we use the keyword for, and inside the parentheses we have our initialization statement right here, followed by a semicolon, that's important, followed by the condition, followed by another semicolon, and then finally the update, all inside the parentheses. So it's kind of nice when you can package it up like that. It's very important you get it in that correct order, so it has to be initialization, followed by condition, followed by update, okay, because that's where C# expects to find them. And then the body, same deal. Now in this example, I could have left off the curly braces because I only have one statement inside, so I could have totally left those off. And actually I would have. I was just trying to stay consistent here. Notice that, all right, so first let's see how this works. So the first thing that happens when we come to this loop is we create this variable and initialize it to 0. That only happens one time, only at the start of the loop. Notice we're allowed to create this variable inside here. We're doing a declaration inside here. So that's allowed here. So we do that once, then we immediately check the condition. All right, so 0 less than 4. If that's true, we come in here, print out. The next thing we do is go up and do the update. Once that's done, we come back over and check the condition again. If it's true, we keep doing the same thing over and over again. Everybody see how that works? Just the exact same way as the while loop worked, except we've just changed where things are located. And in this case, you could use whichever one you want. It doesn't make a difference. I kind of think that the for loop looks a little nicer this way, and I can also get rid of the curly braces as well. But either one is just as valid. So any questions about this one? Like I say, same exact output as previously. And again, there's the basic structure. Don't forget those semicolons. That's really important. Sometimes people forget that. You have to have semicolons to separate each section. Also, it's common, especially with for loops, to see the control variable named I. And that's okay. You can actually name it whatever you want, but if you see it, named I, that's pretty common. This is one case where it's okay to have a single letter variable name. Okay, because remember I said, you typically want to use descriptive variable names, but this is okay. You might also see J, K, things like that as well. We'll see some examples later, but that's okay, like that.
So that's only okay because you don't have the one thing in there. You don't have to.
Well, it's okay because it's more of a convention. It's common to see that. Normally you want to stay away from single letter variable names, but for some reason inside of like loops, like especially for loops, it's okay to, if you have a control variable that's a single letter, your control variable, the one that's controlling the loop. It probably has something to do with brevity, just keeping things smaller. But like I say, you can do this. You can call it, I called it count here instead of I. That's perfectly fine. Now, in this example though, one thing about the for loop, this variable that you're creating here, so I'm declaring it right there, it only has scope within inside the loop. What scope is where it can be seen. So it only exists inside the for loop. When this for loop quits, count is destroyed. Actually, it no longer exists. So if I come down here, this console write line is outside of the loop. This is going to cause a compiler error because count no longer exists at this point. That's an important, it's kind of subtle, but it's very important. Variable scope is an important thing. We'll talk about it more later. So right here, this will not work. Now, if I wanted something like that, what I would do is like this. Here, count has scope inside main. It can be seen everywhere inside of main because it's declared directly within main. Up here, I declared it in the loop, so it's only in the loop. But here, I declared it directly within main, so it's available all throughout main. So this time, this works okay. Okay, because of a difference in scope. Everybody understand that?
Is that why you have a semicolon inside the four parentheses?
Actually,
Is that what go back up there with that?
no. The reason why I have the semicolon is because you always have to have the semicolon. A for loop always has to have two semicolons inside the parentheses. Even though, now I'm allowed to do this, I can leave that blank and put this up here. There's nothing that says I have to declare the variable inside the parentheses, the loop control variable. I can leave it blank and instead do it out here. But I still got to put the semicolon. Now that said, would I do this? I would probably just turn this into a while loop, because when you leave pieces out of for loops, it kind of looks strange. Okay, but you can do it either way. Everybody, does that make sense? I mean, I can even leave like this out. I could do this, but then of course I'd have to come down and do, you know, this, and so this is valid. But it looks weird. It's totally valid though, but I still have to have the semicolon. All right? I can even leave the condition out if I wanted to. What happens if I leave the condition out?
It will just keep that.
It'll be an infinite loop. Yeah. If you don't have the condition, you've created an infinite loop. So you'd want to make sure inside your loop that you have some mechanism for getting out of the loop. That's a little more than I wanted to talk about, but anyway. Any questions? So the important thing there was variable scope. That was really what I wanted to talk about. No questions? Let's go to the next one, the do while. So with a for and a while loop, there's no guarantee that they're going to execute even once, right? So if the condition is false to begin with, they won't execute. So if you want to guarantee that the body of a loop is going to execute at least one time, do while. It will do that. So here's the format for it. So I've declared my loop control variable up here, my initialization statement, and then I'm going to use do, and then a curly brace. It's common to have your curly brace on the next line. Technically, C# doesn't care. There's my body, then a curly brace that lines up right beneath that one on the next line, followed by while. So that's why it's do while this is true. Do this while this is true, while this condition is true. So there's my condition. And don't forget the semicolon at the end. That's a common mistake. So it works just the same as a while loop. Actually, it works just the same as a for loop too. Just with that difference that the body's gonna execute at least once, because the condition is checked at the end instead of at the beginning. All right. So what we do in this case is we print out when we go in the first time, we're going to print out 0. We're going to increment. Then we're going to check the condition. If the condition is true, we go back up and repeat again and again until it's false, and then we just pop out. Piece of cake, right?
So in this instance, if you initialize it at 5, it will still run one time. Then come down, check condition is false, and then not do it again.
Yeah, good point. That's a good point. Yeah. Yeah, so no matter what I initialize it to here, it's going to run at least one time. That's correct.
Would you say that do while more efficient than just
No. Is there a reason why you think it might be more efficient?
Because it would just go ahead and print it out already, and then we'll go down and check it.
Oh, I think I see what you're meaning. Let's see. We're going to check. I think we're going to do the same number of checks, though, aren't we? So if I do print 1, yeah, we're going to have the same number of tests. So if you run through each one, you're going to have the same number of condition checks. So yeah, there would not be an efficiency difference. But that was a good question. Let's see, what else? Oh, let's see, the curly braces. If you only have one statement, technically you don't have to have the curly braces, but nobody ever does that. So with the do while loop, you always put the curly braces. Or at least I don't know anybody that does it. It just looks weird without the curly braces. So even if you only have one statement, I do the curly braces.
But when you say if you don't have but one thing in the color brace, you don't have to have it. Would you usually be doing more than one thing to the same variable declaration, or would it be different normally?
Oh, you can do all kinds of things. You can have several different variables, and you could be doing different things. Like I could do, let's say, I don't know, I'll just call it A, set to 1. Oh, I'm in Word, that's why it's coming out blue. And then I could do, I could increment A, for instance, and I could do another. I could do whatever I want. I'm just making up stuff. This is not meant to be practical, just an example. So is that what you mean? Like, can I do? Yeah, you can have different variables going on, and then I can also do things like, let's say count less than 4 and A less than, I don't know, whatever. Okay, I can do things like that. I can. So there's another variable in the mix.
See, if you did that with both, so because you used and then, it would have to be, both would have to be true. Both conditions would have to be true before it would execute, right?
Correct. Yeah. So A has to be less than 10, count has to be less than 4. So what's going to happen here, though, is that count is actually going to wind up killing this before A gets anywhere near 10. But again, this is just a quick example to show you, how I can throw in another variable and also use a logical operator. Yes?
So the other way to put two variables like the conditions together, you use the operators?
Yeah, if you want to have two different conditions, you have to use logical operators to combine them. Yeah, always. That holds true for if statements and if else and all your loops. Basically anything that has a condition. That reminds me, I saw somebody doing something like this the other day. So as long as count is greater than 2 and less than 4. We can do that in math, but we can't write it like that in programming. So we'd have to write, instead of doing that, we'd have to write and count less than 4. Still works the same as in math, we just have to write it differently.
So you can only be assigned one.
We can only check one condition at one time. So this is 1, and then this is 1. Is that clear?
Because C#, I guess, can only check this against this. It can't check this against this and then check that result against another one.
Yeah, something like that. Yeah, that's the way they wrote it, the language. And I mean, I don't know any language that's not like that, honestly. All the C family languages are exactly like that. All right, so just some simple examples here. Can everybody see that okay? It's in black and white, but what I got here is I've got a loop control variable, so I just initialize it down here to 5. So I got a while loop that's going to count up to 50. Notice this time I said greater than equal 50. That's important because it's going to, as long as, so when count gets to 50, it's still going to loop one time. So in the previous example, when we got to 4, we actually quit because we said less than 4. If we said less than equal to 4, we would have printed out the value 4. But basically the gist of it is, use the correct operator for what you're trying to do. So this is going to start out 5 less than equal to 50 is true. We're going to go in and print 5. And then we're going to increment count by 5. So count plus equal 5. So that means just add 5 to count, right? So that plus equal operator. The next one, so this is just the same thing using a for loop right there. That's all there is to that. So we just put everything inside those parentheses and it does the same exact thing. Which one looks better? I don't know, you tell me. It's your choice. I kind of like the for loop better. I kind of tend to use for loops myself, but here's the exact same thing using a do while loop. So I said, we can convert any loop into the other, right? So this shows you I can do that.
Just a matter of rearranging.
Yep, just rearranging it. This is just an example that counts down. So here I've got count starting at 50. And then as long as count is greater than or equal to 5. And then, so print out the value. And then I'm going to decrement it. So count minus equal 5. That just says subtract 5 from count each time. So that's just an example of going in the opposite direction. Any questions about that one? Now make sure, you don't do something like, what's the problem there? You're starting at 50, so
That'd be an infinite loop because it's going to try to keep going until it goes below 5, and it's never going to because we keep adding increments that we.
exactly, because count starts at 50. We print out 50. Then count becomes 55. Well, 55 is greater than or equal to 5, so we just keep going up and up and up. We do have an infinite loop. It's going to keep printing out all the values up, adding 5 each time. So, yeah, you want to make sure you get your logic right. So C# will do it, but it's not what you expected. So you want to subtract so you eventually get down below, your ending value. Now, I'm doing a lot of counting programs here. It's a good way to teach loops. You can do a lot more than just counting, though. Okay, anything, like I say, anything that you want to repeat, we can do in a loop. But here's another counting one. This time, though, I created a variable called start and a variable called end, and I named them that because that's their purpose. I'm going to have the user enter I've already got a starting value set to 0, and then I'm going to have the user enter an ending value. Now you got a homework problem where you're going to have the user enter a start value and an end value, and you're going to count from start to end. It's actually very simple, similar to this one. But what I do, so I'm going to grab the ending value from the user. No big surprises there. We just use a read line, convert to int 32, and plug it into end. Okay. Now in my loop, all I have to do, there's nothing says that I just have to use numbers in my condition. Okay, I can create conditions using all kinds of things. So while start, which I said was 0, is less than or equal to end, which is whatever the user types in, what I'm going to do is print out start, increment it, and then go back up. Eventually start's going to become greater than whatever the ending value is, and that's going to cause my loop to quit. Now, what do you think it would take to do one that prompts the user for a starting and an ending value? What do you think you'd have to add?
And so enter another console write line and get rid of the initialization value of type of start.
Yeah, you can go ahead and get rid of the initialization up here. Although technically you don't have to, but you can. It would look better. And then you really just have to repeat this code and just change the, change that to start, change that to starting. And do you have to change anything about your loop? Anything need changing there? No. It's good just like it is. It's that easy. Now let's see. All right, this is an example with nesting. I'm going to have a variable called response. I'm going to get a response from the user. It's going to be a string. And then I'm using a do while loop here. So what I'm going to do is this. So there's my do. There's the end of it. There's while. So this says do while response is equal to capital Y. String literal, right? It's got double quotes around it. So as long as the user presses a capital Y, it's going to keep going. What happens if the user presses R? It's going to quit. Yeah. Because that's not what the program expects. The user presses a capital Y, a lowercase y, what's going to happen? It's still going to quit because it wants a capital Y. What if I do this? It will accept either a capital Y or lowercase y. So that's one way to check, to allow the user to do multiple things. So that's good. So I use the OR operator, the two pipes. So let's take it back that way. All right, so we will go into the loop one time, right? Because it's a do while. We'll execute this body at least once. So this nested for loop, I can do that. I could have made a while loop too. I could have done whatever. So it's going to count from 1 to 10. All right, it's just going to print out 1 through 10. Then it's going to come down and ask the user, would you like to print another 10 digits? And they do Y or N. We're going to get the response, just like this, right here. And then we're going to test it. So if it's Y, we're going to come back up and do the same thing again, and again, until they press something other than capital Y.
What makes it count all the way to 10?
Because of the logic I put in here. So I said initialize it to 1, and then as long as it's less than or equal to 10, we're going to print out the value. It goes to 10 because we said less than or equal to 10. What would happen if we did this? Yeah, it'd print from 1 to 9.
Okay, Okay, so this is, so this will print out 1, 2, 3, 4, it wouldn't just print out like number 9, right?
Oh, no, it's literally going to print. So let's do this. So I starts at 1, so it comes into the loop, prints out 1, okay, because the condition is true, so it prints out 1. Then it does the update to 2. Then it comes back 2 less than or equal to 10 is true, so now we print out 2. So it's going to print out 1, and then on the next line, because we used right line, it's going to print out 2, and on the next line 3, and so on and so forth. Any questions about that one? Any other questions? Let's see, that's my last example for now.